So, other than that, I think I'm ready to introduce the next speaker, Kristoffer Larsen, who has very kindly stepped in the last minute to take over where there was a very late cancellation. So we are very grateful for that. And just for to make it interesting to him, we were at a very nice beer bar yesterday, and I know he likes beer. So we got this specially made for you. It's an evil porter, and I know you like beer. Give him a hand.
Thank you. Good afternoon. My name is, as Alan said, Kristoffer Larsen. I work as a network development engineer at Telia company, based here in Copenhagen, but with tasks in the Nordics. So I want to run through what we have done to, as part of a bigger project, to deploy some residential IPv6. First, the history of IPv6 in Telia company has been since 2011 with the World IPv6 Day. We actually launched a 6ID service. We didn't advertise it, it just showed up. If people went into their router, their home gateways, they could enable this. We put up IPv6 DNS resolvers and the works around getting a residential IPv6 service up and running. So it's not something new for us. We also did between the IPv6 day and the launch, there was a year there where we were registered in Google DNS, so they would return IPv6 quad A records for our customers on IPv6. But only very few customers has used this service. Yeah. So I think sorry. So as a part of a bigger project where we want to redesign our service model for the mass market realizations in the entire Nordics. The old service design is something from 2002, 2003, based on ATM, QoS, and DSLAMs and multiple PVCs, and we've been dragging that along ever since. Going to VDSL didn't change it, going to fiber didn't change it. So something had to be done to make it more modernized. It became more and more challenging to do these residential gateways that needs to have a lot of special features to route traffic onto different PVCs. And this old service was built back when there was no Wi-Fi. There were Wi-Fi routers, but it was not a commodity, and people didn't have smartphones, so they didn't need to talk to their TV or anything. So everything was on different networks in the home. Even without a router, this service was initially introduced. We also had the problem that we have a huge amount of, or not only amount, but also models of access nodes that has been installed over the last 17 years. And a lot of the security features for the service was implemented in these access nodes, ARPS security and split horizon for the residential customers. And as the amount of access nodes or type of access nodes grew, it became more troublesome to introduce new services. So that was also one of the motivations to do a redesign. And then there was also a desire to enable native IPv6. That's why we're here today, or I'm here today to tell about that. And even on very old platforms that have no support for IPv6, so we could not use the fancy DHCP snooping methods or any security features. So a redesign has been made. This is just to tell you about the basics why we're doing this. It's nothing new. Each customer will get only one IP address, and we will run QS on that as good as possible, or at least one IPv4 address. I will come into the addressing scheme of IPv6 later. We use extensive use of VLAN Q&Q, and as much as possible we move all the intelligence into a BNG where we select a few vendors for BNGs. So we can do service development 1 or 2 places instead of in 25 different models of access nodes. Some features still need to stay in the access nodes, IGMP snooping, where we'll go into using MVR, multicast VLAN registration. And we don't see multicast for residentials being a very long-term thing we need to migrate to IPv6. So that will probably stay to IPv4 until it dies. So what was decided with regards to address assignments for the IPv6? I know some of the other people doing it in Denmark are doing a /48, but it becomes a lot of IP addresses if you need to give /48 to 1 million customers. So what's decided was to do as Comcast are doing in the States and many others, is /56 for residential, which we believe is enough for the close future. And there is also a /64 for the WAN, so it's a proper routed connection. Each BNG provides addresses from pools. /40 was actually not needed, but our registry thought it was easier not to calculate with hex values, and so they want to hit the 4 nibble points, and a /48 for the WAN links. This lease time we have on IPv4 is so we can reuse IP addresses for people being offline one day and online the next day. It was not really needed. We have plenty of IP addresses, and it was actually decided that we will keep the lease for 30 days. Not the lease, but there's an administrative timer in the network equipment that keeps the lease even though the customer is disconnected. So it's more or less a static IPv6 address. Of course, network changes, or if you move around and change access node or something, you will get a new address, but you will more or less have a static IPv6 prefix delegation, and also the WAN link. When going from opt-in service to actually putting this into the throats of all the customers, there is some security considerations. This is not taking into account the network, it's more taking into account the customers. So it was important for us that what people believe is a security feature in a residential gateway NAT, which it gives some sort of security, but it was not really intended for that. But the same thing, we need that for IPv6, so there is a stateful firewall. We do the same thing, unicast reverse path forwarding, as we do for IPv4 on IPv6. Some of the things we need to work on was the abuse handling. We need the logging of the DHCP logging or lease logging needs to be able to handle IPv6. And we also made sure that our DDoS platform were able to take IPv6 flows and make sure that we didn't get any nasty attacks on on IPv6, as we see always, all the time on IPv4. Just jump in if there's any questions, or if you prefer, I can also have a talk with anybody afterwards. But specifically on the residential gateway, we were lucky that a lot of our gateways were actually native supporting IPv6, and they are based on this OpenVRT as a basis. Long down, then our vendor has taken it and put some stuff on it. But there was very good IPv6 support. There is even forwarding in the hardware of IPv6, so these gateways that we sell together with 1 gig connections, they can always also do full duplex 1 gig for IPv6. That was also important for us. And then people always ask me, what about the incoming connections? And yes, that's a huge hole for now in our service. There's actually in our gateway no way to open incoming connection. As from the security considerations, it was important that we did not allow all TCP connections or connections coming from the world into whatever people had connected, fridges, IP cameras, and they are bad enough as they are, opening UDP ports without customers knowing it. So by default, we have to block it. Otherwise, we cannot enable it as a service that you put onto 1 million customers. And you can't make any firewall openings in the current software. That's something that we are working with our vendor on. We're also considering doing or getting PCP support for IPv6 implemented, or following what other techniques there is coming for that. We did also enable IPv6 remote management, so we can do our remote management things via IPv6. We tested that. We are not using it currently. Then there's some QoS considerations doing this, especially on very old access platforms. They don't support marking or classification based on IPv6 in any kind. Fortunately, the very old access platforms tend to also have very slow uplink because they're based on ADSL or 100 meg Ethernet. So it's the upstream traffic in our aggregation network is not that loaded from these old access nodes. So, but what we're doing is that the CPE can prioritize this because obviously it's aware of IPv6, so it will prioritize the neighbor discovery and DHCP and also the other management protocols we use upstream. So it's stupid to have the lease go down because the customer is loading the line. Of course, the lease will come up because the load will disappear when the lease disappears. But so we at least try to avoid these things. But this also means, as I explained before, no TV, or at least multicast TV, over-the-top TV is working perfectly fine for IPv6, but no, these multicast old TV distribution models or VoIP is not something we have enabled or are planning to do right now. Downstream traffic still works as even on the older platforms because we use MPLS COS in the aggregation network, or we use VLAN 802.1p marking, and that old equipment can handle that also. So downstream traffic, you will have your DHCP prioritized higher than the rest of the best ever traffic. Then there's some things, if you want to do this, you should take note of. Different vendors have different views of what a subscriber session is. I heard some of the vendors were here today, so maybe they know this, but so I won't point any names, but one vendor takes a subscriber session as one, and you will have your queuing and you will have your scalability of one subscriber session, and then underneath that you can have like different IP next hop flows or next hop routes. So you can have a lot more of those than you can of subscriber sessions. Where other vendors, they take one IP address or one IPv6 prefix as a subscriber host. So suddenly if you enable IPv6, you will have half the scaling in your BNGs. So that's something you need to have under control. But at least if you choose the correct vendors, it's not going to be a problem. No names mentioned. Very simple run through of how we are actually doing the migration. We are preparing the customer to be moved to this new BNG. Of course, there's lots of steps because we also changed the service model, but that's not really relevant for this. But what we do is that we move the customer to the new BNG, and because they get a new IP address, or they call home sometimes, one or the other, it will call our tier 69 server, and this one will notice that it needs a new configuration, and it will push out the 6ID, or disable the 6ID, enable native IPv6, and then the important thing that it will enable the IPv6 on the LAN side. Because our solution has actually been so that ever since we got the 6RD implementation, it was activated all the way into the router. What we disabled was the router advertisement on the LAN side. So that's what people could enable and disable in the LAN. So that's very smooth. I was surprised when we did the first 1,000 customers. Is nothing going to happen? It turns out very, very well. We have been, as we've only done this in our pilot country, Denmark. We are not very big in Denmark, so that's some problems that we've had from these migrations. Has been very few. We did the first 2 months, we didn't hear anything. I was talking to our customer care several times a week. They heard nothing. It wasn't until we began ramping up from 25,000 customers to around 50,000 that there were some complaints that now some strange Akamai service were unreachable. And it turned out that Akamai actually had a error in their DNS implementation that gave they couldn't control our IPv4 or IPv6 caching location, so they gave us some data center several AS away in south of Germany, and they noticed that more and more traffic were coming this strange way, so they put some cap on it. So we had some heated discussions with Akamai about getting this fixed, and they implemented a fix for that 1.5 weeks or 2 weeks, I think it was. Some of the other problems that might not be so big to you, we have a strategy not to have any caches from anybody. So Google are directing us to different caches around in the Nordic regions, and they don't send you to the same place for IPv4 and IPv6. That's just how they've made it. They don't know enough of our network to really do that, so when they do load sharing, it seems like they're doing it semi-manual or have some half AI doing some funny things. But it turns out sometimes some videos are broken on some caches and some videos are broken on other caches. And customers began complaining a bit about this, and I'm not 100% sure that this is actually a IPv6 problem. It's more they had some Google cache problem. Then some of our subcontractors on access lines, they either claim that they have no IPv6 support, which actually means they don't want to forward our neighbor discovery or router advertisement packages. So we've been having some minor trouble tickets towards those. Yeah, that was what we have of problems, and some numbers from what we have done. It's difficult to get exact statistics for anything. We've been looking at the AppNIC because they look good, even though they are not correct, because they have no idea how many IPv4 netted solutions we have and how many subscribers we have or mobile devices. But they say we have close to 50% of our users that are IPv6 activated in 3308. That's the graph from where you, down here you can see where we started, ran a pilot, and then ramped up over ran the pilot over the summer vacation and ramped up afterwards. So we reached a point where we have 80% of the IPv6 eyeballs in Denmark, according to AppNIC, so that we are happy about that. Hopefully some of the big players will come in and take our position, but that's how it is now. Unfortunately, our BNG has a bug, so we can't differentiate the traffic upstream to the customer or upstream from the customer, whether regards they have IP or if it's IPv4 or IPv6. So I only have some statistics of the downstream, but that shows over all the customers that we have enabled IPv6 on, that 29.5% of the traffic is actually IPv6. So there's a So there is, it shows there is content out there, and you probably all know that Netflix and HBO and all the big players, they have content on IPv6. So we're getting there. We're getting there. So my conclusion on this is just get it done. No whining. We ourselves will continue in Finland and Sweden for this. Estland or Estonia, I can't remember the names, but they've Elion. They have actually been doing this the same. We did this last year. They did 3 years ago or something. So we have plans to go forward with this. So that was, sorry, I still have some time for some questions or a discussion.
We have a question over here.
Hi, do you have any time frame on when Telia company in Sweden will actually deploy this?
That's,
or is that just, we're going to go there and teach them during a 1-hour meeting?
There is a time plan.
I don't trust you.
We will hopefully start a pilot after summer. The thing is that Sweden is, they have a different BNG platform than we have in Denmark. So a lot of the testing has to be redone or redeveloped. But it will be a pilot, but there is things when you have 50,000 access nodes, takes longer than it does in Denmark. So it will be a rollout. I wouldn't think we'll be done before 2019.
Thanks.
All right, we have another question over here.
Hello. I'm George from Internet Society. Well, congratulations. I had lots of more questions, but then you just answered my questions during the presentation.
Oh, sorry.
But I still have 2 of them.
Yeah.
2 of them remaining. Did you ever had a look into the balanced IPv6 security for CPEs? There is a draft.
No.
That's much better.
Okay.
It's from Swisscom, and it's not just by default blocking everything, because that's not inside the end-to-end principle of the internet. If you just block everything,
Yeah,
right?
yeah.
So please have a look. It's very simple. It's balanced IPv6 security for the CPEs. And the next question is,
I will try to force our CP guys. I'm working in the network department. I was really pounding them just to get this in there.
Okay, the next question is, you said that prefixes are somehow stable. Does the DHCP server gives the prefixes out of the pool, and if you reboot the DHCP server or a BNG, will the customers get different prefix, or you put them in a radius actually, and you make sure that everybody gets the same prefix for lifetime?
There's no guarantee that you'll get the same prefix for lifetime, but it's not stored in a way, but it's synchronized, so we should not have a situation where we ever turn off our DHCP. But so there's a redundant pair that synchronize this information, and they save this lease based on your incoming port identity, so it's not based on your MAC address. So if you switch your router, you will get the same. We had some internal discussions on what to do if people put 2 routers on there, and we sort of said that this thing with bridging and multiple PCs directly on the internet connection is something from the past. Now we have prefix delegation, and we would like also a feature. I'm trying to pound our CPE guys that you can actually request a prefix delegation from the CPE and get a /64 or 62 or something on the CPE, from the CPE to your own equipment or IoT device or whatever you have. So yeah, that's where we are now with the, I went a little bit further than the DHCP, but that's how it is. So you can have one prefix delegation, and you will have one WAN link for your link.
Because we are currently, as we speak, we are working on the best current operational practice document that talks about what size of the prefix operators should choose to give to the end customers, and the second part is, should they delegate it dynamically or statically? So I would love to have a chat with you afterwards.
Yeah. We have had some internal discussions, and the time frame didn't allow us to be very scientific about this, and we say, okay, others are doing like this, let's roll with it.
No, because basically what you're doing is in line with the best current operational practice document that we are writing. You're doing the right thing. Just make sure it's static. Thank you.
Thank you.
Thank you. There's another question over here.
Apart from the well done thing, did you do any education on your first level, second level people to be able to debug related issues that could arise from running dual stack?
That was actually, I don't know if you want to, I don't know what you did, Martin. You did something.
I talked with our first level and second level support, and they said that, or I said to them that if they had any issues with IPv6, direct the questions to me at first, because then I'll look into it and see how much info they needed actually. But we had very few issues. There was the Akamai and the YouTube or Google cache issues, but that's approximately it, actually. So
one of the things we did before implementing the first customers was we made sure that all this was visible in our support systems. So our support guys can see the allocations, and they can see if clients behind the RGV or the home gateway has an IPv6 address, and it also shows them if they are running some of these anonymous things that they will have 10 addresses, and so. But also, to my surprise, there's not really been anything, and I think we are not the first ones to do something like this. I mean, Comcast has done it for 40 million users, so it's a very proven technology, and all the hiccups with sites that didn't work and all these things, they have been ironed out years ago. So we are just extremely slow in the Nordics.
Hello, Christian from Wondercom. I would just say that for the help of first-line support for IPv6, there's actually a RIPE document that Jan Church has written. It's called RIPE 631, and it has a guide to how the first-level support should debug on calls from end users that have IPv6 problems.
Yeah.
And
Thank you.
We'll post it in the channel also.
Any other questions? We have a good amount of time. Over in the corner.
Did you uncover any interesting bugs in your vendor equipment during the implementation, or was it a smooth implementation?
We didn't discover any interesting bugs, but there were some announcements from the vendor with regards to neighbor discovery that forced some upgrades earlier than we would have done before.
All right. Any other questions? Over there.
You're getting good exercise today.
Yeah. My iPhone have been bugging me.
Related to the BNG, apart from the difference in counting users, did they perform according to the vendor specs, or how are they performing? And also, sorry, just.
The question, yeah, as I heard, the question is if they were performing according to the vendor specifications. Yes, I would say so. We have the implementation we have done here in Denmark is based on one vendor, and what we are continuing with in Sweden is a different vendor. And I would say we've had very little issues with the Danish vendor compared to what we are facing in Sweden. Performance-wise, if you are talking forwarding, we have not discovered anything. They do native IPv6 forwarding, and they have sufficient route entries and do access lists and hardware and everything. There's no difference there. Where we are running into problems is with the scaling. Can you put 60,000 residential subscribers in one device if you enable IPv6? And there is a huge difference on that, or on one line card more specifically. But yeah, and there we are running into some issues in Sweden. Yeah, where the resources are not one, but as soon as you enable IPv6, you will use 2 sessions for each user. So suddenly you need to buy 200 more routers.
Were you already using BNGs in your setup so that this change regarding IPv6 was cost neutral, or did you introduce your BNG to be able to support IPv6?
We introduced BNG as part of this larger redesign of the service, not only for IPv6. So yeah, that was some new devices, but that's also, the alternative is to swap 20,000 old access nodes. That also has a high cost.
We can go there. I can inform you that I reached my move goal according to my Apple Watch about an hour ago.
Morten Brørup from Smart Share Systems.
Yeah.
You mentioned that one vendor treated the IP version 6 and IP version 4 subscribers as two,
Yeah.
and one vendor treated them as one.
Yeah.
Was that a cost issue only, or did it also cause some technical issues?
That's the hardware resources. I know nothing about money. No, but that's the hardware resources.
So it's only a resource issue. So the resources are half. There are no other related issues to it.
Queues is also if you want to do real traffic shaping on the customers, there is also different limits of queues, but that's not really related to only IPv6. That's just the nature of these BNG systems.
But you can still, even though they require two sets of resources, you can still manage them as one, more or less.
I'm not sure I understand that.
Are they treated? So the vendor that treats them as two separate.
Yeah.
Are they in all areas treated as two separate? So you have to go into two different identifications and even two different systems, or is it still easy to manage them, although they are two different queues and two different licenses?
It's not two different systems as such. You log in and you can see one session or the other, or you have it in the same radios database or these kind of things. But and you can select these two sessions to have the same queues, so you share some of the queues, but there's still resources for the subscriber session or IP session. So it's something that we spend enormous of time on, and there are different vendors has different, and I try not to name any names here, but there is limits on subscribers, there's limits on how many next stops you can have to the users, there's limits on how many queues, there's limits on how many policers if you run QoS there's limits on how many route schedulers and how many layers, and there's limits on everything, and you really need to test the scaling well.
Okay.
That's more or less my recommendation.
So for instance, if you're using work conserving quality of service, they cannot be part of the same scheduler hierarchy, or so they're two separate.
They can,
even though they require two sets of resources.
Yeah.
Okay, thank you.
Yeah. It's at least on the vendors that we have evaluated 3 vendors. So yeah.
All right, we are going to stop for questions here and use a little of the extra time we have to set up the next speaker. So thank you very much, Kristoffer.
Yeah, thank you for having me.
And Kristoffer will be around, but not for the social, as far as I know. So, but maybe you can catch him in one of the coffee breaks and have a chat with him there. Okay. All right. It's also a service announcement that there's another talk just started next room. So if you want to catch Henrik Kram